Hi viewers, welcome to this video on Cramer's rule. Actually, I want to teach you how to use Cramer's rule to solve a pair of simultaneous equations. And in linear algebra, Cramer's rule is an explicit formula for solution of a system of linear equations with as many equations as unknowns. So it's actually valid whenever the system of equation has unique solution. So in simple terms, if the system of equations does not have unique solution, this method may fail. So in simple terms, this method of solving a system of linear equations uses determinants to solve system of equations. But those equations or system of equations must have the same number of equations as unknowns, right? So I want to use a particular example here. So let's say we have 2x plus y is equals to 4, and another equation x plus y is equals to 3, right? Yeah, so this is a system of equations with two unknowns, x and y, and we are going to use Cramer's rule to get the solution, right? Okay, so what does Cramer's rule say? So we're going to generate this matrix here, 2, 1, 1, 1. Actually, 2, 1, 1, 1 are elements coming from this system of equations, that is 2, 1. And it's always important to remember that whenever you don't have a coefficient indicated here, just write a 1. So 1, 1. So we have 2, 1, 1, 1. Then we write x, y. Then we have 4, 3. And when we do that, then we now get this A as a matrix that we have in front here. Have 2, 1, 1, 1. Then I will have another matrix we call A sub 1, which is going to be a matrix formed when we remove this first column and replace it with 4, 3. Right? So we have 4, 3, then 1, 1. What I've just done is that I've removed the first element column or elements in the first column and replaced with what I have on the right hand side, right? So from there I'm going to have A sub 2, which is nothing but a matrix formed when we take the second column and replace with 4, 3, right? So we have 2, 1, then we take 4, 3. So I want to show you what you're going to do with these three matrices. The first one, I'm going to put a star here to indicate that's a very unique matrix. So the other two, that is A sub 1 and A sub 2, are going to help us to determine the values of x and y. Okay, so the first thing, because I said that this Cramer's rule method depends on the use of determinant, we're going to find the determinant of the first matrix, determinant of A. And you know, determinant of any 2 by 2 matrix is given by AD minus BC, where A and AD, BC are elements of a matrix. So we're going to have A, B, C, D, and so we take AD, that is 2 times 1, and then minus 1 times 1, right? So this gives me 2 minus 1, which is 2. 2 minus 1 is just a 1, right? Yeah, that's just a 1. Right, so that checks. Then we come here and find the determinant of A sub 1, which is nothing but 4 times 1 minus 3 times 1. So that is 4 minus 3, and you're going to get a 1. Okay, then we find determinant of A sub 2, which is 2 times 3, right, minus 1 times 4. So we are taking 2 times 3 minus 1 times 4, and this gives me 6 minus 4, which is a 2. So what are we going to do with these determinants? We are going to take the first determinant, which is determinant of the matrix A, which is 2 1 1 0, and we write it in the denominator, and this is the way I want us to solve for the value of x. So x is going to be equal to determinant of A sub 1 over determinant of A. So the reason as to why we say that x is equals to determinant of A sub 1 over determinant of A, you remember that we took, for us to get A sub 1, we removed the first column, which indeed replaces all elements that symbolizes or represent x, and we replaced with these two numbers on the right hand side of the equation. So that means that in place of x, we replaced with 4 3 to have a new column. Okay, so that's why we are coming here and taking x equals to the determinant of A sub 1 over the original determinant, or the determinant of the first matrix we extracted from the system of equations. So this gives me the first one is, we have determinant of A sub 1, which was a 1. We divide by determinant of A, which was just 1, and this gives me a 1. So the value of x here is a 1. We shall confirm and see whether that's true. To get the value of y, we take determinant of A sub 2 over determinant of A, right? Again, the reason as to why we do so, it's because when you look at the matrix A sub 2, in a place where we are supposed to write the x values, or the y values rather, we are replacing with 4 3. So that's why we come here and use determinant of A sub 2 over determinant of A, and this gives me 2 over 1, which is nothing but a 2. So these are the two values of x and y, and if we want to replace them here and check whether it works, we can take 2 times 1, which is very quickly 2 times 1 plus y is 2, right, from here. So we have y is 2, so we have this is 2 plus 2, which is 4. That holds true, it's a 4. Then the second one says 1 plus, y is 2. We have a 3. That holds true. So that's what we call Cramer's rule, as a method which is used in linear algebra for solving a system of equations with as many equations as the unknowns. All right? Yeah. Thank you.